So getting to the home stretch here, we're at lab 11. Let's take a look at this. Yeah, shape's important. So we, of course, again, a lot of this is in the lecture class. This is a theory called valence shell electron payload repulsion, or VSEPR, sometimes called VESPR. So this is pretty much common sense. Linear is when you have two groups, no lone pairs. If you have three groups, no lone pairs, it's planar. If you have four groups here, no lone pairs, this is tetrahedral. If you have four groups, three bonding, like in ammonia, one lone pair, it's pyramidal. And if you have four things, so what's a thing? A thing is an atom and a lone pair. So water has four things. It has two atoms, both of which are bonding, and two lone pairs. So four things, two bonding, two lone pairs. So four things, two bonding, two lone pairs. This is bent. So something to note, if it's a double bonded something, say you have like carbon double bonded O, that counts as one. So the double bond O counts as one bonding group. It doesn't count as two, it counts as one, just so you know. And then bipyramidal, there's 5, and for 8 is octahedral. Bipyramidal is sort of like a planar, the trigonal planar here in the plane and the equator, and then above and below. Octahedral, this has the same symmetry as a square. It's got 4 in the bottom, 1 above and below, and these are all 90-degree angles here. These are going to be, this is going to be perpendicular for these above and below. The axial ones are above and below. The equatorial ones, I'm sure you can figure this out. It's going to be 360 degrees divided by 3, or 2 pi radians divided by 3, whatever you want to call it. So you could easily get these pictures if you looked it up on the internet. So if you do VSEPR Google image search, you'll be able to find all sorts of pictures. So central atom, prelab exercise, they're easy. The first atoms here, these are all the central atoms. And region of electron density, 2, 3, 4. And I already talked about bent and not linear with the groups. So first thing, the magnets, you put these magnets together and you see what you do. And the idea is these will all be evenly, more or less evenly distributed. Modeling clay, take these pictures, take these and you use the modeling clay. You have a big ball in the middle, and then two. So you have a big ball in the middle and 2 on the sides for 2 atoms. I'm sorry, it's just 2 next to each other. Linear, 3, like I said before. Planar, you got 1, and you have them coming out in the different angles. Bent, it'll just be like, well, actually it might be best to start with a tetrahedron. Start with your tetrahedron, and then take one off, and you have the pyramid. Take one off, and you have the bent. Or take 2 off from them. You take 1 off from the pyramid, you have the bent. So that's the way I would do this one. The bipyramidal, you have 3 in the plane and 1 above and below, 90 degrees. Octahedral, all of them 90 degrees. So I want you to do is I want you to take a picture. Take a picture of your octahedral one. And the most common mistake students make is that they do the octahedral, and they do the tetrahedral, octahedral, these things, they do them all in 2 dimensions rather than 3. If your pyramid here is the same as your planar, you're wrong. So if you go through and your planar is the same thing as your trigonal pyramid and your trigonal plane are the same thing, it's wrong. Planar is flat. This is 2D. The pyramid is like the pyramids of Egypt. The pyramids of Egypt are square. You have a square base on the bottom, and then you have it come in. You say the square base on the bottom, and you have the apex. The triangle pyramid, it's going to be a triangle base. So triangle base, and then one on the top. So these are in 3D. Make sure the students, when they make mistakes on this, they usually give me things that are 2D instead of 3D. Octahedral, they'll take a central atom. They have a central atom, and they'll have 6 around the side. It's in 3D, so it should be kind of like a diamond shape, kind of, sorta. So, and if you have trouble doing it, just just look at the internet, and you can find some pictures there. And you should be able to do this. So if anything happens, let me know. This is a fairly simple lab. Take a picture. Give me a picture of your octahedral, because that's usually a telltale sign. So let me know. Actually, let me know if you have any questions, and I will see you next time.